Hello and welcome to 5-Minute Physics. Today we'll be talking about magnetic force on a particle using the right-hand rule. Let me check volume. Okay. Alright. So the right-hand rule is a physical way to demonstrate magnetic force on a particle in a magnetic field. So you've got your hand right here, and we'll use that to model the magnetic field force. So let's use velocity in red. Alright. Say the charge is in the middle of your palm, just imagine. And it's moving this way, out from your thumb. So this would be the particle's velocity, v. Now your fingers point in the direction of the magnetic field, which, in this case, would be pointing upwards. Okay, and that's B, the magnetic field, from your fingers. Just imagine that. Alright, now the particle itself, being in the middle of your palm, is going to experience a magnetic force from being in the field. And that force would be from your palm, out from your palm, just like this. So this is force, magnetic force. So if the particle was in your hand and it's moving in this direction, in a vertical field, it would experience a force that way, which would result in motion that would probably take it, let's use orange since it's a combination, in this direction once you add up the vectors. So that would be the actual motion of your positive particle. Now if it was a negative particle, it would move in the other direction, out from the back of your hand. So let's say if this was negative, it would go that way. And that would be your negative particle. So that's the basic right-hand rule. Now, quick note on magnetic fields. Magnetic fields are annotated like this. We see one with X's, it means it's, so to speak, going into the page or whatever surface you're working on. We see one like this, represented with dots, it's coming out of the page at you. So coming towards you and going away from you. Okay? Now let's apply that to what we just talked about. So we have this positive charge, this particle, and it's in a magnetic field. And this magnetic field is moving away from us. So it is going away from us like so. Alright, so we have our particle, and the velocity is in this direction, upwards for us. And the magnetic force, based on the right-hand rule, would be going this way. So you can imagine that with your hand. You would have fingers in the direction of the field, like this. I'm going to draw a vertical hand. We'll see how this turns out. Use your imagination. Alright, so let's call that hand. And your thumb points in the direction of the velocity. And your fingers point in the direction of the field. So your fingers are coming out at us, or in the other direction rather. And the force is going this way since that's where your thumb is pointing, and so the charge would be, wait a sec, I think I did that wrong. Hang on. Sorry about that. And it's backwards. I did that last time too. Okay. So if I were to draw this correctly, we'd have the hand over here, thumb in this direction, fingers away from us. Alright, so there you go. Charge going that way, that's B, the magnetic field, sorry, not charge. Velocity moving in this direction. That's V. And your force would be out from the palm of your hand, since this particle is in fact positive. And there you go. That's the basic right-hand rule. Now, the motion of a particle in a field like this, as you can see from the dotted lines here, vector addition. When you have a vector going this way and a vector going this way, you add them up to find the actual direction. So, you've got the velocity pointing upward and the magnetic force pointing sideways. So, if your particle has that kind of forces pulling on it in those two directions, it'll end up going like this. And if you really just integrate those, you end up with a circular motion. So the particle is moving in a circle. And a lot of times you see that with solar flares on the sun, where... Oh, that's an ugly color. Let's try that again. Yellow. This is the sun. Everyone's favorite star. And you've got a solar flare coming out like this. Whoop. Solar flares are actually just big magnetic field lines. If you were to take a cross-section of a solar flare, you would see something like this. Not actually with X's, of course, but that's what the magnetic field looks like. So, if you have a particle that's inside of a magnetic field like that, it would usually end up spinning around like this in a kind of a coily motion. So because of that circular motion, you get this nice spring shape. So your particle would be moving that way. So that's how it works, and that's the basic right-hand rule. Thanks for watching, and we'll see you next time.